Hello everybody, this is Mr. Bowman. So today we're going to be looking at the ALEKS topic, identifying geometric sequences and finding the common ratio. So with this one, they gave us a series of sequences, and what we're going to do is we're going to see if these are geometric or not by trying to find the common ratio. If we can find a common ratio to all of the terms they gave us, then we can say what that is, and that having a common ratio like that signifies that it is geometric. If we can't find one, then we'll have to say it's not geometric, and we won't identify the common ratio because there isn't one. So what we're looking for here is, are these getting bigger or smaller? And that will help us figure out if we're kind of multiplying or dividing. Remember, it's always multiplying, but for some people, if you're getting smaller, instead of thinking multiply by 1/3, they easier to think divided by 3 or whatever the case may be. But let's look at this one. So these are going down, right? So absolute values are going down 4 to 1, 1/2. So we're going to attempt to find what our common ratio is. So there's going to be something that takes us from 4 to 2, something from 2 to 1, and something from 1 to 1/2. And to find that, you just take the second number divided by the first for each of these sets. So here I have 2 divided by 4, which is 1/2. 1 divided by 2, which is 1/2. 1/2 divided by 1, which is 1/2. Since it's the same for all of those, it is geometric. And that 1/2, that number that keeps showing up, is your common ratio. Okay, kind of hard to see in there. So it is geometric, and the common ratio is 1/2. Here we're getting bigger, but it's kind of an odd jump. We're not doing a nice 9, 18, 27 pattern. So we're still going to do our little divisions. So 12 divided by 9. So that one doesn't come out evenly, which is why it doesn't look like there's a pattern automatically. But what we want to do is we're going to take that fraction and we are going to reduce it, and that's fine. We'll leave it in its reduced form. So if we do that, we can divide both of those by 3, and we'll end up with 4/3. So 9 times 4/3 would give us 12. For this next one, we're going from 12 to 15. So 15 divided by 12 gives us, divided by 3, so 5/4. I don't even have to check this last one, but you can if you want. You get 6/5. As soon as you get 2 that don't match, double check them. If they're accurate, any of these don't match, it's automatically not geometric. Okay. This is actually an arithmetic one because we're adding 3 each time. So anytime the repeated pattern is multiplication, it's geometric. If it's addition, it's arithmetic. All right, looking at this last one here, we have 3, -30, +300, -3,000. This pattern sometimes confuses people, and they think it can't work because how are you going to flip signs like that? And you still want to check it because this alternating pattern does have instances where it works just fine. So check all of these. So -30 divided by 3 is -10. 300 divided by -30 is -10. -3,000 divided by 300 is -10. So this one actually is still geometric. It's an alternating geometric sequence, and the common ratio is -10.